Hi everyone, and welcome to Learning Space. This is the show from CosmoQuest. We are back after a brief hiatus. I hope you guys enjoyed the pre-recorded videos we had coming up every Wednesday for the last few weeks of some fun science activities that I did mostly through Glass, through Google Glass. So those are all up on our YouTube page. It's Astrosphere Vids on YouTube. Learning Space is a weekly show about all things astronomy and space education and outreach, any kind of interesting topics that we find along those lines. So we are back with a weekly live show. And this week, let's see, hang on. Oh, first I want to remind you guys on how to comment. I have needed a reminder on all of this since I've been away from it for a while. If you leave a comment on the event page on Google+, where this is currently embedded, we will see those comments. If you leave a comment on the YouTube page where this is playing, we will see those as well. I don't have access to the Twitter comments anymore through Comment Tracker, but I do have a separate window up. So if you use the hashtag #LearningsSpace, I will see those as well. So feel free to comment, say hi, and ask questions as we go through the show. So this week, I am joined by Miller Goss. Hello. And Miller Goss is a radio astronomer at the National Radio Astronomy Observatory in New Mexico. And he has a book that just came out today. I got my copy a couple days early from Amazon called Making Waves. So this is a book about Ruby Payne-Scott, who is the first female radio astronomer. And anyone who has seen me on any of these hangouts knows how I go on and on about how much I love doing radio astronomy. And so I absolutely had to have Miller Goss on to talk about this really cool subject and this really cool person and the whole process of learning about her life. So, Miller, why don't you start with just telling us a little bit about your background as an astronomer and then how you got to find out about Ruby Payne-Scott.
Thank you, Nicole. It's just fantastic that you've organized this. It's so much fun for me, and you know my passion for Ruby. Mm-hmm. But let me give a little bit of my background. This is a monumental year for me because you'll not be surprised that I graduated from Harvard College 50 years ago this year.
Oh, wow. Congrats. Happy graduation anniversary.
And I had a degree in astronomy, and I started a PhD immediately 50 years ago at the University of California in Berkeley. And in those years, one went very quickly through a PhD, and 4 years later, I was ready. And my wife and I, Libby, had a goal, a dream of going to Australia for many different reasons. One, of course, was that Australia was very famous as a country where radio astronomy excelled, and it's some of your participants may know that after World War II, that the two countries where radio astronomy grew very fast was both Australia and Britain. So we ended up in Australia. I went for 2 years, ended up staying for about 6 or 7. Fell in love with the southern sky. I used the Parkes radio telescope that some of you may know from the very interesting and not very truthful movie called The Dish. Mm-hmm. But nevertheless, when I was in Australia those years, my boss was a man called John Bolton, and he was very, very famous, very renowned. In fact, he had started radio astronomy at Caltech in the 1950s, and to come back as he was Australian or British and Australian, and started radio astronomy. He told me one day, as I was sitting in his office at the Parkes radio telescope, "You should have been here 30 years ago. The most outstanding physicist of the lab was Ruby Payne-Scott." And he said, "No, I'm going to correct that. She was one of the most outstanding physicists in Australia at the time." Wow. And this was probably 1976, 77. And many years later, in the 1990s, in fact, I remembered this. And I started thinking about it, and I thought, there must be a great story here. I should try to find out what's going on. And I started researching, found out a lot about her. I met her family. And in the 1990s, many of the radio astronomers that had been her colleagues in Australia in the 1940s and 50s were still alive, and I learned a lot about them. And this became an incredible passion for me, and you were a victim of that passion, Nicole. You were a summer student here in 2004 and 2005, and you heard me talk about this a great deal. I was already working on the book, and in fact, by 2009, the first book came out. The first book was called Under the Radar. It was for a professional audience, and the new book that you showed to your participants a few minutes ago is a popular version that was published last week in Germany by Springer. So that's a long version of how I got into this.
Awesome, awesome. And so you know, her story wasn't well known. We hear about, you know, Koljansky, and we hear about Gert Reber, and we hear about, you know, all these early pioneers in radio astronomy, and yet her name wasn't well known. And in fact, you know, however many years ago that was, when you did a Google search for her name, you found almost no information, if any. So she was not a well-known topic. But what did she work on in her early career?
Well, her early career, she was, we think, was the third woman in Australia to ever get a physics degree. This was in the mid-1930s.
Wow.
And in the mid-1930s, of course, it was very difficult for anybody with a physics degree to get a job, especially a woman, because it was in the middle of the Depression in Australia, and the only real profession open for a woman in 1936 and 37 in Australia that had a science degree was to become a school teacher, a high school teacher, which she did. World War II came along, and the Australians, of course, joined World War II in 1939. 2 years before the Americans did, because the Australians declared war against Germany following the British Commonwealth, and this changed the career of many women in Australia, of course, as they joined the armed forces. And the handful of women that had physics degrees were all snapped up immediately, and they started working on radar.
Okay.
It turned out that she was a whiz at working on radar. She liked electronics. She was good at mathematics, and she became a very important participant. And you can see it was so important because the men who were electrical engineers and physicists were sometimes, of course, being drafted in Australia and sent to fight in the war in New Guinea and places like that. So she had this background working on radar. At the end of the war, they wondered what they were going to do. And they'd heard about radio astronomy. They had read Carl Jansky's papers, and they heard about Gert Reber for the first time. And they thought, gee, we better think of something new to do that's not related to wartime research. And they started observing the sun. And she made incredible breakthroughs starting in 1945 and 46 in detecting radio emission from the sun using radar receivers that the Australian Army and Air Force had left behind.
Yeah, there were some of that was highlighted for her, what would have been her 100th birthday, the Australian Google Doodle for her birthday. I can't remember when this was. Was this sometime last year?
Yes, here it
is.
You
have it! Hang on.
It was her. It was the
last year, May of last year.
May 28th last year, and this was a fantastic publicity stunt for me. I had nothing to do with it, of course. But I started getting emails from friends in Australia, and there's an 8-hour time change, and they all were sending these emails saying, you've got to look at this. And this actually shows on the image, and it's in the new book, this image, and it shows the fact, there it is. You can see she's radar, she's got earphones. In fact, they did use earphones. But you can see the sun, and you see on the right of the image, you see there's something called a PPI, Planned Position Indicator, that she was one of the leading experts in the world, and you all recognize that from movies and everything as the way that radar reception is still done. So she understood electronics, and then she discovered all these amazing things on the sun in 1946. And there was a piece of good luck here, Nicole, that it's always worth pointing out. That it was a good piece of luck is that one of the most active sunspot maximum of the modern era began in 1946. That's a coincidence.
Yeah, I mean, that's exact opposite of what's happening now, right? We're in a pretty low maximum. Yeah, so I was looking at some of the pictures.
Maximum, and hence it was a great time to be a solar radio astronomer.
Yeah, she was responsible for characterizing this in the Google Doodle. They specifically have the Type 1 and Type 3 solar radio bursts,
Yes,
right? And
she
so
in fact is. You can say she is a discoverer of both Type 1 and Type 3 burst.
Okay, cool. And and I remember people sent me that image going, "Is that Ellie Arroway from Contact?" It's like, no, that's a real person. But that's what sprung to mind for many people who saw that, because they sent it to me as well for that reason.
You know, I hadn't thought of that.
Yeah, because of the headphones. And yes, it's true, they did actually, I mean, but they were seeing signals from the sun that were super huge, right?
Yeah,
We're talking millions of Janskys, and most of what we look at now is a millionth or less of a Jansky.
Yeah, in fact, it's a 1 billion Janskys.
Oh, 1 billion Janskys. Okay, so yeah, really active sun. Really
It may be the largest radio signal ever detected on Earth that she participated in.
Wow. So what kind
just to finish the story, the reason that she dropped off of everyone's radar, as it was, because she got into a lot of trouble because of the regulations influencing the employment of women in Australia, including a married woman's role in the workplace, and of course there was no maternity leave. And at the age of 39, which was a very old age in Australia in 1951, she gave birth to her first of 2 children. So she had to quit. So you see, a radio astronomy career from 1944 to 1951. So she laid the groundwork, and then she disappeared, and a few years later she came back into the workplace, but only as a school teacher. So she never appeared as a radio astronomer again.
Okay. So it was partly, so mainly it was the pregnancy and not having maternity leave that seemed to drive her from that position, but there was also issue with her marriage as well, right? You couldn't be a permanent employee if you were married as a woman. Was that correct? Or okay.
Yeah. If you were a woman, and if almost any job in Australia in 1943, 44, and got married, you lost your permanent employment, including school teachers, which seems just absolutely outrageous. And of course, the women in 1943 thought this was outrageous also. I mean, they didn't think this was fair.
Right.
And the difference was they all complained about it among themselves, but Ruby then actually stood up publicly and fought against this, and actually was involved in a public campaign with the bureaucrats and the government research organization objecting to this rule.
Yeah, she wasn't meek and quiet, as I understand it, from all the people that you've talked to that knew her. She wouldn't just lie down and take it, right?
Yes.
She was much more outspoken. But she was also married for some time and had to hide the marriage.
That's right. She got married to Bill Hall, a remarkable man that we know a lot about, in 1943. And he was very proud of his wife, and he, in fact, later on, about the time that Ruby died in 1981, Bill told Fiona Hall, his daughter, a very famous artist, the daughter of Ruby, the second child, said, "You never know the hardships that your mom had to go through in the workplace because she was a woman." And you saying this to his daughter, who had grown up in the 1960s and 70s, you don't know how lucky you have, is that many of these discriminatory activities have disappeared now.
Yeah, but it still took some time. I mean, that didn't happen right away.
Yes, in fact, it was many years. It was in the 1960s and 70s, only in Australia, when women received equal wages. It was actually built into the law that a typical woman would earn 2/3 or 3/4 of a man's wage, even in professional employment.
Wow! Oh my gosh! But were her immediate colleagues, very accepting of her as a woman, or were there frictions as well?
I mean, there was some friction, only in the sense that she was so strong-minded and she was opinionated. But in fact, we do know that her male colleagues, who typically were much younger than her. They had graduated from university in the early 1940s,
Okay.
and so she was more experienced. The fact that she was very gifted as a mathematician, she was very helpful, and some of her men employees or colleagues have told me, in fact, that if they would have a math problem, some complicated differential equation to solve, they would come to Ruby and she would solve it for them. She was very generous. They all respected her. In fact, they all knew that she was married in 1943, and they were part of this quiet conspiracy that in fact, never talked about it.
Wow.
So in fact, she did have a lot of admiration from, I would say, from 90-odd% of her colleagues, because, not surprising, she had to be the best, she had to be the most intelligent, and she was generous with helping her colleagues. And there were 2 other women, incidentally, there. That's also very important. And I've now realized, and we've written about this in the book, that these 3 women who were all physicists bonded together and they helped each other.
Mm-hmm, mm-hmm.
There was a little clique of them helping, and sometimes they would get into conflicts with each other, but they realized that this was self-defeating.
Yeah. It's like, all right, it's us against the patriarchy, guys.
Yes.
Wow. We have a question from Todd Howard asking where the term Jansky comes from.
Oh, good question. It comes from the first radio astronomer, Karl G. Jansky, an American of Czech origin who grew up in Wisconsin, graduated from the University of Wisconsin in, I think, of the order of 1930-31, and went to work for Bell Telephone Labs. And there's a long story, and I won't go into the details. There's a fantastic Wikipedia article about Karl Jansky that explains what he did at Bell Telephone Labs, and by serendipity, a serendipitous discovery, he discovered the radio waves from the cosmos when he was investigating interference that impacted long-distance radio telephone communication across the Atlantic.
Yeah, so that term was named after him in his honor.
Yes.
So that's energy density coming from used in radio observations. Yeah. Okay. Cool. Thank you, Todd. So what was it? Did they talk about what it was like? Okay. So the early days of radio astronomy. They've just discovered that there's this cosmic static and solar static and solar noise, they're calling it. Did they talk anything about what it was like just having the whole field open to them? No one actually knowing what they were looking for.
And you see, they had a special problem. These folks were physicists and electrical engineers. They didn't know any astronomy. In fact, it was a couple of years before they actually met a live astronomer. So we've been told that Ruby actually was desperately trying to learn astronomy, and she bought this very famous book that went through, what was it, maybe 7 or 8 editions by Smart, called Spherical Astronomy. You might have even seen this book, Nicole, when you were a graduate student. Certainly in the 1960s, this was a book that we all used. The first edition came out in the 1940s, and she was desperately trying to learn about astronomical coordinates.
Yeah.
Light ascension, declination. They'd never heard that term.
Oh, wow.
She learned it, and she was actually teaching some of her colleagues, and she would loan them copies of Smart's book. And fortunately, there was a famous optical radio solar physicist, a man called Claiborne was his name, Allen, A-L-L-E-N, who became a very famous astronomer at the University College London. And Clay Allen was working at the Commonwealth Solar Observatory in Canberra, not too far from Sydney, a few hundred miles, and he was very interested in this new solar results. In fact, on the giant solar burst of March 1947 that Ruby participated in, this was the Billion Jansky event, Clay Allen had seen a huge sunspot develop. In fact, that sunspot in March 1947 was, I believe, the 2nd or 3rd largest sunspot in modern history.
Wow. About
0.5% of the solar surface was covered by this the sunspot, and of course it produced these fantastic type 1, type 3 and type 2 burst that Ruby discovered and made all these interesting observations. And you can see the fact that people understood radar, they understood signal processing, they understood how radio telescopes work, and they, of course, were learning solar physics from Clay Allen. He was on the phone with them, he visited them, and was telling them about solar physics, and of course he was a professional professional solar astronomer.
Mm-hmm. So they're learning all of this as they go. This is a brand new field. The astronomers don't understand the radio engineering, of course, right? And so they can only help with part of it.
They weren't even sure. The classical astronomers even had debates among themselves. Were these new folks, were they real astronomers?
Oh, wow.
And in fact, Ruby's boss, a man called Joseph Pawsey, invented the word radio astronomy in 1948. He thought, we're going to stop calling what we do solar noise and cosmic noise. We really are astronomers. We're learning astronomy. We're starting to go to astronomy meetings, and let's have a new term, radio astronomy.
Awesome. And they were publishing too. They were publishing the astronomy journals, and some of Ruby's work was published in Nature as well.
Oh yes, all these first couple of papers that had a huge impact on astronomy were published in Nature, and in February 1946, and in April 1947, the big solar burst. And this got the professional astronomers throughout the world started paying attention to this.
Okay.
And they started writing letters to these folks in Australia.
And were they in support, or were they looking for more data? What were they?
Well, they just kind of started to find out more of what's going on.
Okay.
And it was very important that Joe Pawsey, at least, went on a world tour for a 13-month period. He and his wife got on a boat in Australia in September 1947 and came back 13 months later. They went to the U.S. first. They went to Canada. And then they got on a boat and they went on the Queen Elizabeth, the old Queen Elizabeth, from New York to Southampton. And he was in Europe for about 6 months, and he was meeting all of these folks and giving talks and learning. And it was the ultimate networking experience. And he was sending letters to Ruby all the time. And Ruby was collecting postcards.
Okay.
Trip. And she was thrilled to get a postcard that had the Tower of London, for instance.
Oh, wow. Oh, wow. So she did get credit for her work, but then what happened afterwards that her name kind of got lost in the history?
The fact that she left work, the people remembered her. They talked about her. So when I started working on this in around 1999, there were a couple of sentences about her in history of science books, history of astronomy books, would say that most people thought that she was probably the first woman radio astronomer. They weren't sure. It turns out to be correct. They didn't appreciate all these fundamental discoveries that she had made, like the type 1 and the type 3 bursts, that she understood how to do interferometry, which is a technical term expressing how we achieve high angular resolution. She worked out the mathematics of that process. And so, as you know, I started giving talks, and I've given, of course, mainly many lectures throughout Australia. I believe I've given a lecture in every capital city in Australia except Tasmania. I've been to Hobart, but I've never given a lecture about. I've even given a talk about her in the Northern Territory. And there have been radio programs. If you Google now, you'll find your work on Ruby. Nicole's contributions to the popularization, and then there's the Wikipedia article that I wrote, of course. But there's a fantastic website from the ABC, the Australian Broadcasting Corporation, the Science Show, and when people send me emails and they want to find out about Ruby, I suggest that they look at was it February 2004, I believe? I'm not sure of the year. There's a complete transcript of a 1-hour program that has a very serious discussion by me, but mainly by other people, that knew Ruby, including Ruby's daughter. And so this is a great resource, and it was a way that I got started on unearthing her story.
So how did the family react when you reached out to them that you were
going
to write a story?
And it didn't hurt that both of her children, of course, she always went by the name Payne-Scott, and it was only after she left work that she took the name Hall. Both of her children are very famous Australians. Her daughter is the most famous. If there are any of your participants that happen to be Australian or know Australia, they will have heard of Fiona Hall, who is, I would say, is in one of the top 10 most famous and recognized artists of Australia, with all kinds of amazing artwork. You can look her up on Wikipedia. There's a lot of amazing artwork. In fact, the cover of the new book that you've already shown, this cover, that little piece of artwork there.
Oh, that was done by Fiona.
Fiona Hall.
Oh my gosh.
It's called Reconstructed Art, and it's a reconstructed picture of the famous view of Mount Fuji.
Oh, wow.
From the famous Japanese artist.
You guys can see that.
Hokusai.
I don't know if you guys
and you
can
see it's made out of doilies, they're banana peels, and they're
my gosh.
The pictures of girls surfing with 1950 swimming. It's a bit of a joke.
I didn't look that closely at it. That's awesome.
But that's so most Australians know Fiona Hall. Her artwork is in every capital city of Australia. They have large exhibits. She has outdoor artwork that's close to the Sydney Opera House. There's a picture in the book about that. So that didn't hurt. In fact, Fiona has been incredibly supportive of finding out about her mother. Libby and I had one of the most amazing 2-day visits with Fiona in 2007 in Adelaide, where she lived. And she talked about her mother nonstop for a couple of days. I was recording it all.
Oh, wow.
And we have a great conversation that I have on tape where Fiona has been given a large collection of lobster, isn't it, by some neighbor. So she is hitting the lobster. She's breaking up the lobster with a wooden mallet while I'm recording, and she's telling me all these stories about her mother.
Oh my gosh. Did they know she was so influential to the science?
No.
Oh, wow.
Fiona knew that she, of course, had done this, but she didn't know it. Now, her son is even more remarkable in a sense because he's a scientist. He is undoubtedly the most famous Australian mathematician. He has many awards, many international awards. He was made a member of the Order of Australia last Australia Day, 26th of January 2013. He was made a member of the Order of Australia. He's a fellow of the Royal Society. And many scientists in Australia, of course, knew Peter, and only in the last few years have they appreciated who Peter's mother was.
Wow.
And so he's been a big supporter, but he didn't know many of the details of her science because he's a mathematician.
But that's interesting that they just didn't even know the scientific treasure they had in their household.
Yeah, and they knew that, and she would sometimes tell Peter stories because as a child he was interested in science and in physics, and she would tell him about the thrill she had when she saw the interference fringes from the rising sun on Australia Day 1946. And Peter never forgot this. She appreciated, of course, what she was observing and the implications this had for the whole issue of the mechanism of radio emission from the sun.
Can you tell us a little bit about that interferometer experiment? Because I didn't realize until reading your book that she was at the forefront of interferometry, which is my favorite thing.
We might even show a picture.
Do you have the picture of the? Do you have it bookmarked?
Sea cliff.
I don't have it bookmarked. No.
I'm about to find it. Here it is. This may be too. It's on page 118.
Okay.
I don't think it's going to show up very well.
It's probably going to be a little fuzzy for most people.
It's a little fuzzy for your visitors.
Yeah.
But you can look. It's very simple. You can see you had a radar antenna
Uh-huh.
was no longer transmitting. It was only a radar receiver at this point, which had turned into a radio telescope. It's at a sea cliff. It's looking out at the rising sun. Okay, now you can think about how can the rays from the sun get to this radio telescope, this radar receiver. You can have a direct path. It can come straight from the sun, and it can also bounce off the sea. So you see, you have a fictitious, well done.
Fast Google.
You did it. You found Google. Okay, now you see the direct ray and the pathway. Now Ruby is sitting up in that antenna on the left on the sea cliff, and this is a very high sea cliff. Libby and I have been there many times. It has a height of almost 100 meters.
Oh my
It's
gosh.
about 290 feet, and it's an incredible view. I mean, you're looking out over the Pacific Ocean, and you're only 10 miles from the center, from the Sydney Opera House.
Oh wow.
And it simulates a radio telescope that has the path length of twice the cliff height.
Okay.
You see, this is a pretty cool interferometer. It's made of one single radio telescope, not two, like we're used to. Nicole and I have spent a lot of our lives as astronomers observing with the VLA and the VLBA, and especially you've been a VLBA aficionado for the last many years of your career, observing also at Green Bank.
Yeah, and then I helped build paper.
Yes, that's another interferometer.
You don't understand an interferometer until you build one. That's what I learned.
Sure. And those interferometers, the ones that you and I work with in the modern era, are called Michelson interferometers.
Mm-hmm.
The sea cliff interferometer, I'm sure quite a few of your participants have studied physics, and they know about a Lloyd's mirror, named after the famous Irish physicist Mr. Lloyd. And that's what this is. This is the radio equivalent of an optical Lloyd's mirror. And you see they had it in place, but it's a kind of you have to say it's an inflexible interferometer. You have one baseline. Yeah. But in fact,
you can only see the sun for a short period of time.
Yeah, for about an hour a day, and only at solar rising. So later on, some of Ruby didn't go, but some of her colleagues went over to New Zealand, where the cliffs were almost 300 meters.
Oh, wow.
3 times higher, and you had both an east-facing and a west-facing slope by going to the east coast and the west coast at a distance of only about 100-some-odd kilometers. And they saw the sun rising and the sun setting, and they were also observing the sources that they call the radio stars, which were the first radio sources.
So so they use that to increase their angular resolution, or to get better angular resolution, because the radars themselves had a resolution of what, tens of degrees?
10 degrees. But
so like your hand at arm's, or your fist at arm's length is the the kind of accuracy they had on the sky.
But for the low frequency radars that the Australians had during World War II, they also were seeing Lloyd's mirror fringes from incoming aircraft.
Oh, right. Was that why it was developed?
No, they thought they were physicists. They built it because the sea coast was where the Japanese invasion was going to occur from. Of course, they were getting ready for the Japanese air attacks. In fact, in northern Australia, as many people know, many cities like Townsville, Queensland, Darwin, of course, were attacked by the Japanese naval aircraft from aircraft carriers in February, March 1942. So the expectation was that the Japanese would attack Sydney and Melbourne, etc. It would never happen, but they were getting prepared for that.
Sure.
And they turned on their radars at the seacoast. They saw these fringes, and they were physicists, and they realized what they were. So you see, the sea cliff interferometer principle was already known, but using it as a radio telescope was not known. And Ruby was, in fact, the first person that wrote down the equations that described the response that you showed just a few minutes ago from that interferometer. You can write down the relationships of the size and the location of the source to the response of the radar receiver.
So what did this interferometer help them to see better?
Well, they could tell that the instead of having a 10-degree picture of the sun,
Mm-hmm.
they had an image of the sun with a resolution of about 20 or 30 arc minutes, the size of the
wow.
moon. You see, it's about a factor of
So that's like half
20.
of, just like your pinky finger, even smaller than your pinky finger at arm's length.
And
You
see,
hold
the
that up.
first thing that Ruby noticed, she knew then the fact that she was getting fringes from these type 1 burst on Australia Day, the 26th of January 1946, that the radio emission was much smaller than the total size of the sun.
Okay.
It was about the size. It was somewhat bigger than the sunspot, but it was say about 1/10 of the size of the sun, and hence, to use the jargon that you and I would be familiar with, it had a huge brightness temperature. The brightness temperature was like 100 or 1,000 billion degrees Kelvin.
Right. So it's nothing like the actual temperature of the sun. It's not
That's right.
a thermal source of emission. So they were trying
That's
to figure
right.
out what the heck this was.
And the radio astronomers were also discovering something else at that time, or it was remarkable about the sun. If you observed at high frequencies, like the frequencies at which, say, your communication with your satellite TV works at the sun, you would see the 6,000 Kelvin brightness of the solar photosphere.
Mm-hmm.
As the optical astronomers. But the radio astronomers observing at these frequencies detected this huge solar corona that is often observed in eclipses, of course.
Yeah.
It's many times larger than the size of the sun that we observe, not with your eye. Of course, you should never look at the sun with your eye, but with a special solar telescope. It's many degrees in size, and the size of the solar corona in the radio is a couple of degrees in size, and it has a brightness temperature of 1 million degrees.
Okay. Okay. Yeah, which is what we understand that to be. Yeah.
We understand that to be, and you see, the great thing then about radio astronomy, you could study the solar corona any day. You didn't have to wait for an eclipse.
Right. Right. Yeah. Whereas otherwise, you had to wait for an eclipse and be in the right place and have the right weather to study it in optical. So they were able to.
Not with a radio telescope. You can observe it with a radio telescope through rain.
See, guys, I say this all the time. This is why radio astronomy is the best. We don't need no clouds. We don't need nighttime. That's awesome. So I have a question for you. What was it like doing historical research, and how is that different from the science research you've been doing all your life?
Well, this was painful. Very. But fortunately, our son is a historian of science.
Oh, okay.
That was a big help. Although I have to say he's a very severe critic, but that's very good. In fact, his wife, my daughter-in-law, is the editor of this book.
Okay.
Read when you read the preface. So that was helpful to have a historian of science in the family. But I met a couple of historians of science, and I started learning how to use archives.
Okay.
So what did I do? I went around and interviewed many scores of people, maybe 100 in the end.
Wow.
People that knew Ruby, but of course you realize when you're talking to them about events that had occurred 40 and 50 years previously, that very often the reliability of the details is, not surprisingly, can be questionable. So you realize when you hear something in an interview that occurred long ago, you take it as an indication, but you're not sure you can use it.
Mm-hmm.
Now, the great aspect of what Ruby did and her colleagues is that they work for a government organization. It's like the National Science Organization of Australia, called the Commonwealth Scientific and Industrial Research Organization, and it is an incredible bureaucracy, and everything was put on a piece of paper.
That helps.
Including,
as long as you find them.
Including hostile notes that were written to Ruby by the personnel folks when they discovered that she was married. A little small piece of paper that would be like you were writing a piece of on a yellow sticky. There were no yellow stickies then, of course. And this was a sarcastic note about the fact that she was disobeying regulations, and that was put in her personnel file, and we have that.
Oh my gosh.
And so all the details of her personnel record we have. I'll tell you something in the moment about her ASIO file if you have time. We may not have time for that. That's in the book. That's her security record and the equivalent of the FBI's CIA of Australia, called ASIO, the Australian Security Intelligence Organization. We have her file there. There's something, if you Google Ruby, you'll find people in the National Archives of Australia actually have put up her ASIO file, and about 1/3 of it is redacted. That is, it's completely blacked out. But all the rest of her career, including copies of handwritten letters, etc., were kept in the records. They ended up in the National Archives in Sydney and in Canberra, and I went there, and I have photographed, and I showed you earlier today that my incredible full office is full of notebooks, about 300 of them, that includes all the paperwork that I have had copied in Australia or that I have photographed when I go to the Australian Archives, and that's how you reconstruct her professional story. You put together and you make a timeline of her life. You develop themes. You figure out what she did. They had meetings at work once a week, once every 2 weeks, about discussing the science, and there were detailed minutes kept. And I have 2 or 3 huge notebooks, and we can see what Ruby was saying to her colleagues someday in March 1949.
Wow, wow, that's impressive. I don't think any of us keep minutes that well anymore.
Well, you can see with email. My prediction is, and I'm sure there's some of your participants have theories about this too. I'd be interested in what they think. Yes, ask yourself the question: 50 years from today, would it be possible to reconstruct one of our scientific colleagues' life in a detailed way, like we did from 1945 to 1955? Because there's email, Twitter. You can see we don't write things down. We don't have a permanent record, and it's hard to imagine 50 years from now that people are going to be interested in reading yours and my emails from today.
Yeah, it's a deluge of information now. It might be too much to get a clear picture.
Right. And the other thing I have to say, that piercing together then a lot of the personal details of Ruby's life and her life with her husband and her life as an active bushwalker. It's an Australian expression. You know, she was a passionate bushwalker and did this a lot. And we met a number of people that were still alive that told us about going on hikes with them, and the fact that she was incredibly strong as an individual. In the book, there are pictures of her standing on some of the peaks in Tasmania at Christmas trips. Of course, in Christmas trips in Australia, you would go because it's the middle of summer.
Yeah.
And then the fact that ASIO became interested because they thought that she was left-wing and they thought that she was a member of the Communist Party of Australia. And amazingly enough, they could never figure it out. And with the help of her son, I found a handful of folks in 1999 and 2000 that knew her as a member of the Communist Party of Australia.
Wow, wow. So did that get her much in trouble with her colleagues?
It would have.
Not a big deal.
It was never illegal to be a member of the Communist Party of Australia, but of course it was heavily frowned upon, and there were many informers inside of the CPA, the Communist Party of Australia, that were telling ASIO what was going on. Wow. And of course, you know, this is a pernicious type of reporting, because you can say anything, and things were said about Ruby that are in her ASIO file that were just not incorrect. But they never knew that she was a member of the party. In fact, she was. We now know that. And we're also certain that she broke with the Communist Party of Australia in the 1950s, perhaps at one of the times when many members of communist parties in Western countries were breaking with the Communist Party, at the time of the exposure of Stalin's crimes by Khrushchev, the so-called secret speech. It's a very famous event, and also at the invasion of Budapest and Hungary in 1958.
Okay.
So by sometime in the 1950s, she was no longer a member of the Communist Party.
Okay, so she was
But
probably disillusioned with it. Yeah.
I think she was disillusioned.
Wow. Wow. So she had several. So there were several reasons why they could have had trouble with her. She was a woman. She was married. Couldn't do that at the time. She was a member of the Communist Party, like you said. That would have been a problem with her. She was also an advocate, a really strong advocate for peacetime research, I think, as well.
That's right. She was. She got, at the end of the war, the question was, should the CSRO continue on wartime-related research? During the war, of course, they had heavy security there.
Mm-hmm.
They had to, right? I mean, the security of vis-a-vis German and possible Japanese espionage was very serious. And the survival of Australia depended on this. So the question was, should they go back to peacetime research? CSRO was well known for agricultural research, of course, working on cotton, sheep research, etc. And would they change radar classified research into something that was non-classified, like directional finding, air navigation, working on computers, and radio astronomy? And she wrote articles supporting going into non-classified research, the fact that they can have communication with their colleagues internationally. And ASIO saw this, and they didn't like the fact that she was suggesting that CSRO should not be doing classified research anymore.
Wow.
But they did the classified parts of the CSRO that did continue, like in aeronautical research. They left and went into a separate part of the government, and so CSRO did. They won the battle that day. Right,
and CSIRO is still around today doing scientific research.
Yes, they are still the leaders in radio astronomy in the world, one of the major leaders. Yeah. They're the people who are building the SKA prototype in Western Australia. I spend a lot of time, of course, when I'm in Australia, not only in archives, but working with radio astronomy colleagues at Sydney University, at the CSRO, Australia Telescope Compact Array, also in Perth, where there are many radio astronomers now working on the SKA. And of course, there's lots of recognition of Ruby's achievements now among the astronomical community in Australia.
That's awesome. That's fantastic. That's fantastic. So I want to wrap up with a few announcements, but afterwards I'd like to give you a moment to tell us about your favorite part about researching Ruby. But first I want to plug the book again. This is Making Waves, the Story of Ruby Payne-Scott, Australian Pioneer Radio Astronomer. It's available on Amazon. Guido Vibra has put the link to the Amazon link in the comments for the Google event. I'll be adding that to the YouTube description after the event posts as well. So I got my copy. I'm very happy. Thank you, and thank you, Miller, for giving me the sneak preview as well, so I could read it while I was away. So check out the book. It's a really fascinating story. I love this story, and I'm glad I at least got to see some of it as it's been coming out over the last 9 years since I was a summer student at NRAO. So just to let you guys know, we're actually the My Moon folks, Andy Shaner's doing a hangout starting right after this one at 7 p.m. Central. So that's I can't do math right now in my head. 5 p.m. Pacific. So in just about 10 minutes, there'll be a My Moon hangout. I'll be sharing that link as well. We'll be talking about what the My Moon Street team does and getting people to talk about lunar science and all kinds of weird places. The Weekly Space Hangout is on Friday, so same time, same place, noon Pacific. We'll be I'll be back, and Fraser Kane will be hosting, and we'll be talking about all the news this week in space, in astronomy. And then Sunday night is the Virtual Star Party. Monday is Astronomy Cast, as long as Pamela's travels line up with the correct time. And we'll be back again next week for Learning Space. I'll have Georgia Bracey back, and we'll be talking about more astronomy education from the last conference we were at. So stay tuned for that. I think that's all the announcements I wanted to make. Oh, one more thing. I am teaching a short online course about radio astronomy starting in September. So if you go to cosmoquest.org, and then up at the top at the Educate button and CosmoQuest classes, I think it's being called CQX011. you can sign up for that course. It'll be a short course. It'll just be 4 lectures over the course of 2 weeks. We'll be using the Google Hangouts to do discussions, and to you can learn some more about the terms and the basics of radio astronomy that we've been talking about here today. So I'll put the link to that in the show notes as well. So those are all the announcements I wanted to make. And Miller, do you have any parting thoughts? Something really that stood out to you about Ruby while you were researching her life?
I think the main impression was that she was a passionate person who enjoyed what she was doing. She liked electronics. Radio astronomers in those days, they had to do everything. They had to build the radio telescope. They had to do the observations. They didn't have computers, right? The results came out on pieces of paper.
Oh yeah, I forgot about that. That is like the coolest thing.
And then they had to use rulers and slide rules.
Yeah.
They did have a couple of these mechanical calculators, and they were doing things like Fourier transforms by hand. And you and I have done a lot of Fourier transforms, but never by hand.
No.
and you think about, and then they had to think about the physics of what was going on the sun. They didn't understand anything about synchrotron emission. They were learning plasma emission. It's hard to imagine to enter a field literally from the ground floor, where everything you do is new, and the next step forward, you've got to invent the way to get there. That's an experience I don't think any of us will ever have.
No, that is amazing, and I'm glad we got to. You're bringing us her story of how she was a pioneer in that. So that's really great. So thank you so much. Did want to point out one comment from Guido Bibra. Utterly amazing. This hangout is full of history. I can't even think of a coherent question right now. I'm too fascinated. So thanks for commenting, Guido. Good to see you guys again. I'm waving at you guys in the chat. So it's good to be back and good to be live again. So thank you, Miller, so much for joining me to talk about this. Like I said, everybody, check out the book, Making Waves, all about Ruby Payne-Scott. And I think that's it for this week's Learning Space. So thank you so much. Bye. Hi everyone, and welcome to Learning Space. This is the show from CosmoQuest. We are back after a brief hiatus. I hope you guys enjoyed the pre-recorded videos we had coming up every Wednesday for the last few weeks of some fun science activities that I did mostly through Google Glass. So those are all up on our YouTube page. It's Astrosphere Vids on YouTube. Learning Space is a weekly show about all things astronomy and space education and outreach, any kind of interesting topics that we find along those lines. So we are back with a weekly live show. And this week, let's see, hang on. Oh, first I want to remind you guys on how to comment. I have needed a reminder on all of this since I've been away from it for a while. If you leave a comment on the event page on Google+, where this is currently embedded, we will see those comments. If you leave a comment on the YouTube page where this is playing, we will see those as well. I don't have access to the Twitter comments anymore through Comment Tracker, but I do have a separate window up. So if you use the hashtag #LearningsSpace, I will see those as well. So feel free to comment, say hi, and ask questions as we go through the show. So this week, I am joined by Miller Goss. Hello. And Miller Goss is a radio astronomer at the National Radio Astronomy.
I was ready, and my wife and I, Libby, had a goal, a dream of going to Australia for many different reasons. One, of course, was that Australia was very famous as a country where radio astronomy excelled, and it's some of your participants may know that after World War II, that the two countries where radio astronomy grew very fast was both Australia and Britain. So we ended up in Australia. I went for 2 years, ended up staying for about 6 or 7. Fell in love with the southern sky. I used the Parkes radio telescope, that some of you may know from the very interesting and not very truthful movie called the dish.
Mm-hmm.
But nevertheless, when I was in Australia those years, my boss was a man called John Bolton, and he was very famous, very renowned. In fact, he had started radio astronomy at Caltech in the 1950s, and to come back as he was Australian or British and Australian, and started radio astronomy. He told me one day, as I was sitting in his office at the Parkes Radio Telescope, "You should have been here 30 years ago. The most outstanding physicist of the lab was..."
We hear about, all these early pioneers in radio astronomy, and yet her name wasn't well known. And in fact, however many years ago that was, when you did a Google search for her name, you found almost no information, if any. So she was not a well-known topic. But what did she work on in her early career?
Well, her early career, she was, we think, was the third woman in Australia to ever get a physics degree. This was in the mid-1930s.
Wow.
And in the mid-1930s, of course, it was very difficult for anybody with a physics degree to get a job, especially a woman, because it was in the middle of the Depression in Australia, and the only real profession open for a woman in 1936 and 37 in Australia that had a science degree was to become a school teacher, a high school teacher, which she did. World War II came along, and the Australians, of course, joined World War II in 1939. 2 years before the Americans did, because the Australians declared war against Germany following the British Commonwealth, and this changed the career of many women in Australia, of course, as they joined the armed forces. And the handful of women that had physics degrees were all snapped up immediately, and they started working on radar.
Okay.
It turned out that she was a whiz at working on radar. She liked electronics. She was good at mathematics, and she became
the observatory in New Mexico. And he has a book that just came out today. I got my copy a couple days early from Amazon, called Making Waves. So this is a book about Ruby Payne-Scott, who is the first female radio astronomer. And anyone who has seen me on any of these hangouts knows how I go on and on about how much I love doing radio astronomy. And so I absolutely had to have Miller Goss on to talk about this really cool subject and this really cool person, and the whole process of learning about her life. So, Miller, why don't you start with just telling us a little bit about your background as an astronomer, and then how you got to find out about Ruby Payne-Scott.
Thank you, Nicole. It's just fantastic that you've organized this. It's so much fun for me, and you know my passion for Ruby. But let me give a little bit of my background. This is a monumental year for me because you'll not be surprised that I graduated from Harvard College 50 years ago this year.
Oh, wow. Congrats. Happy graduation anniversary.
And I had a degree in astronomy, and I started a PhD immediately 50 years ago at the University of California in Berkeley. And in those years, one went very quickly through a PhD, and 4 years later, Ruby Payne-Scott. And he said, no, I'm going to correct that. She was one of the most outstanding physicists in Australia at the time.
Wow.
And this was probably 1976, 77. And many years later, in the 1990s, in fact, I remembered this. And I started thinking about it, and I thought, there must be a great story here. I should try to find out what's going on. And I started researching, found out a lot about her. I met her family. And in the 1990s, many of the radio astronomers that had been her colleagues in Australia in the 1940s and 50s were still alive, and I learned a lot about them. And this became an incredible passion for me, and you were a victim of that passion, Nicole. You were a summer student here in 2004 and 2005, and you heard me talk about this a great deal. I was already working on the book, and in fact, by 2009, the first book came out. The first book was called Under the Radar. It was for a professional audience, and the new book that you showed to your participants a few minutes ago is a popular version that was published last week in Germany by Springer. So that's a long version of how I got into this.
Awesome, awesome. And so you know, her story wasn't well known. We hear about, Call Jansky, and we hear about Groot Reaver, and